Already we have covered a few of the topics in which the magnets introduction, magnet properties, magnetic properties already we have covered. And in the last session we have also deal with the force on a conductor carrying current in magnetic field. Already that experiment was elaborated. If you bring any magnet near to current carrying conductor, that current carrying conductor will experience a force. Or if you place current carrying conductor in external magnetic field, that time also the conductor will experience a force. Now today we are going to see how this direction of force is determined, and this direction of current is determined by Fleming left hand rule. Introductory, last time we have seen that what does this Fleming left hand rule states? It states that the direction of force or motion of a current carrying conductor in a magnetic field is given by our particular thumbs. If we hold our forefinger, thumb, forefinger, and the middle finger of our left hand, remember left hand, perpendicular to each other in a such a way that the forefinger points the direction of the magnetic field, the middle finger will denote the direction of current, and the thumb will denote the direction of force or motion of the conductor. So this is a very simple rule. You have to just put your left hand in a such a way that your thumb, forefinger, and the middle finger, these all three are perpendicular to each other. Once we know the direction of magnetic field and the current, we can identify the direction of force in which it is acting. Now we shall see what exactly the electromagnetic induction is. In day-to-day life, we have many applications of electromagnetic induction. For example, the electric bell. When someone comes at our home and put button on the doorbell, the bell rings. So this is also example of electromagnetic induction. The cooler, the fan, these are also using electric component. For example, electric motor. Uh, some kind of electromagnetic induction is also responsible for that. So here now we shall see what exactly the electromagnetic induction is. Now we have already seen that a force is being experienced. Now this motion, if we set a magnet into the motion with respect to coil, or we will change this in such a way that there is a change in magnetic field across a current carrying conductor, then a potential difference is get induced or produced in the coil, and that produced current is called as induced current, and this phenomenon is called as electromagnetic induction. I repeat, when the motion of magnet with respect to coil or change in the magnetic field induce a potential difference in the coil and produces induced current, this is called as electromagnetic induction. So what is the meaning of this motion of magnet with respect to coil? So when there is a current carrying conductor, look here, we have not applied any potential difference across this coil or a wire, current carrying conductor. But once if we set a magnet near to it into the motion, then a current is being generated into the coil without any battery. So this phenomenon, when magnet is set into the motion, when it is made in and out, the current get produced, and we can check or detect the current with the help of either galvanometer or ammeter across the conductor. This phenomenon is called as a electromagnetic induction. This first case we have seen for change in motion of magnet, and the second case is the change in magnetic field that produces induced current. Both are actually equal. Here we are changing the motion of the magnet, and now here we are changing the magnetic field. Both are actually same. What is important is that the change in the magnetic field. If we set magnet into the motion, that will also change the magnetic field across point to point. So similarly here, now we use instead of real magnet, we will use the electromagnet. For example, if you are looking in the figure, there is a coil 1 and coil 2. Across coil 1 there is a battery is connected, and across coil 2 there is a galvanometer. So when we see that uh, that coil 1, when key is kept close, current starts to flow through this coil and a magnetic field is being generated. When we make this on and off, the coil 2 gets induced current inside in it. So in this way also we can say that there is a electromagnetic induction, the new phenomena. Now we are going to see the electric motor and electric generator, but before that we should know what is meaning of direct and alternating current. Direct current is always direct current. AC and DC, they are shortly called as AC and DC currents. In day-to-day life, in our daily appliances, we generally use the alternating current. Direct current is used by cells or battery, which are used in our vehicles or torch or digital watches. So what is direct current? Direct current is that current which always flows in one direction only, and whose magnitude will remain same or constant with respect to time. That current is called as a direct current. An alternating current, the current that reverses its direction periodically or its direction change with respect to time, that current is called as a alternating current. In our country, our power supplies, that is connected with alternating currents. All day-to-day appliances, electrical appliances, they are connected, they are operated by alternating current. Its frequency is said to be 50 hertz. That what does it mean? That means in 1 second, in every seconds, the direction changes 100 times. So what is the advantage of AC or DC? That it can be transmitted over long distance without much loss of energy. That is the advantage. We shall see in details much about it in the next session by covering these topics like electric motor, electric generator, and domestic circuits. Till then, keep studying, continue regular your study. If you have any doubts, you can ask personally as well as in the classroom. Thank you.